MUC is the method that really can get the, YP of this kind of differential equation, right? Yeah, don't get confused. This star means, just special, okay? It's nothing, mathematical, but it's a special function, okay? So we have what? Coefficient here, right? Is this coefficient this? Actually not. Okay? This coefficient is the coefficient in YP. Of course, because we are getting YP, right? So this coefficient is the coefficient in YP. Wow, what's that? We have coefficient in YP. That means it is composed of many functions, right? So YP, you already saw that, right? Right? It is composed of many functions, many small functions, and linear combination, right? 1 times x, 1 times 1. That's the decomposition of this YP, right? There could be many different functions, and they are linearly combined. So that coefficient is not decided, right? So we have to decide that coefficient. We have to decide 1 and 1, right? We can generally express this to be k1x plus k0 times 1. Okay? And then we decide k1 to be 1, k0 to be 1. That's a method. Okay? So MUC is method of undetermined coefficient in YP. This is the method determine the coefficient in YP accordingly. Okay? All right. One thing, this one is very easy and powerful, but okay, this one is easy and powerful, relatively easy. This is not really easy, but relatively easier than the other method. Okay, but you got to be careful, right? This one is not magic wand. It's there's a limitation, right? Number one limitation is it cannot handle P of X, Q of X stuff, okay? Only handles number coefficient, A, B, okay? And secondly, the R star is to be a special function. It must be a special function, otherwise you cannot solve it. Special function that has functions that have, okay, this is that have derivatives. Their derivatives written in terms of a finite number of other functions. Our mission is we need to get the functions in Rx is given, right? Then our mission is to find I'm calling it family of YP. Family of YP. Family is the function or the general linear combination we need to find. Okay? All right. Let's say in the equation R, K is given. k is constant. Okay, so number. R is 1 or minus 10, 1000, whatever. Okay, real numbers. Then our family, or the most general case of the primitive function, is this. Okay? So if you make, this is a primitive form. Eventually, this one turns into C 0 times 1, right? To make it the most general case. Okay, but it's a primitive form because we cannot go right away here because we need some more consideration here. Okay, I'll explain that later. What about xn, the polynomials? Okay, which is n is integer, right? N is greater than 0, n is integer, right? It's a polynomial, x to the. Then our primitive form of family functions are x to the n minus 1, x 1. Okay? Then finally it will be kn times x to the n plus k0 times 1. Okay? Finally, the most general form should be this. What about e to the kx? It's e to the kx. Okay? Then the most general form will be c times e to the kx. Okay? If it's given as sine kx, then we should have cosine kx, sine kx, probably so c. I don't know. This k and c's are arbitrary. Just arbitrary. Anything you want. Okay. So don't worry about. This. Okay, so it's cosine kx is same thing. Y sine and cosine is given, just one function is given, but the primitive form pair is pair all the time. It's always pair. Sine and cosine, it's from e to the ix, the complex numbers, okay? So it's always have to be pair. Sine and cosine. That's the better reason for this. Okay? All right. And that's the most popular function that we can solve using MUC. Okay? We could have more, but that's enough for our purpose. Okay? But we are not done yet. We have one more step. Not one more step, another item, which is product of the functions above. What's that? We need a combination of this. Right? It could be any combination, any product of the given functions. So k times xn plus e to the kx, right? That's another possibility, right? K times xn times e to the kx sine kx plus e to the k x square. I don't know. Okay? Any product will be given, right? Then our family will be, we can write it that way, all product of the individual family members. E to the x times x square r이 이렇게 주어졌다고 해보세요. 오케이? 그럼 프로덕트라 그랬지? 프로덕이면 여기 지금 곱하기가 있다는 얘기죠. 그렇죠? 뭐 더하기도 한번 해볼까? 1. 네? 자, 곱하기 더하기 다 나왔어. 그렇죠? 프로덕의 엘리먼트들은 다 나왔어요. 그러면 e to the x는 뭐예요? 패밀리가 e to the x라 그랬죠. 그렇죠? 자, 곱하기 그렇지? 프리미티브 펑션이라고 했어요. x 제곱은 뭐라고 했어요? 제곱 x 1 right? 더하기 1 그쵸? 그럼 또 이건 뭐야? 여기 그랬죠. all product of the individual family members에 대한 all product이라고 했죠. 그럼 이거를 이렇게 놔두면 안 되고 e to the x square e to the x e to the x 플러스는 뭐 더 어떻게 할 수가 없죠. 그렇죠? 이래서 또 어떻게 돼요? 이게 끝이에요? 아니죠. 이거 안 보이나? 이게 이제 패밀리죠. 패밀리 조합을 구하는 거예요, 한마디로. x제곱 x1 곱하기 e to the x plus 1 is x square e to the x e to the x e to the x plus 1 that's the family. 그럼 yp는 이 패밀리 멤버들 다 리니어 컴비네이션. 오케이? 하나, 둘, 셋, 넷. So k3 times x square e to the x plus k2 x e to the x plus k1 e to the x plus k is not. Okay? The most general case of the family members. The most general case, linear combination of the family members. That's what yp from MUC. Okay? And then what? And then you do this whole thing, right? And then plug it into the original equation, and then rearrange the equation, and then you'll be able to compare side by side. Then you can determine K3, K2, K1, K0 eventually. And then your final YP will be accordingly. Okay? One last thing to remember for the MUC. So the differential equation is given like this: 0.001 x squared. Okay, and you have to do YH first, right? All the time, right away. So lambda square plus 1 is 0. So from lambda is plus minus I. Okay, so you're gonna get complex. So our YH will be A cosine x plus b sine x. Okay, so it's a complex conjugate. All right, so let's see. Now it's time to get yp. Okay, and let's say we have yp will be kx squared. Let's see what's going to happen when we do this. Okay, we didn't fully generalize it yet, right? But let's see what's happened. Okay, so yp prime is 2kx squared, yp double prime is 4k, and we plug it in, right? So sorry. Okay, so we plug it in. So 2k plus kx squared, which is 0.001 x squared. Okay? Then we need to compare both sides, right? So, yeah, k is 0.001, right? But wait, k is 0, so that doesn't make sense, right? That's not consistent. So this method doesn't work. This try fails, okay? That's why we need to do that generalization. We need to linearly combine all the elements, otherwise it won't work. So our yp is k2x squared plus k1x plus k0. Okay? And you differentiate it. 2k2x plus k1 yp double prime 2k2. And you plug it in, okay? Plug it into the equation, and you rearrange the equation, and then term by term you compare them, then get k1, k2, k2, right? k0, k1, k2. So from the calculation, it is what? k1 is 0, k naught is minus 0.002, k1 is 0, k2 is 0.001. Okay? And then that's our k, yp, and the final y will be yh plus yp will be a cosine x plus b sine x plus k2 is 0.001 x squared, k1 is 0, and k0 is 0.002. Okay, that will be our final solution for this non-homogeneous equation. Example 2. Alright, so y double prime plus 3y prime plus 2.25y equal minus 10 times e to the minus 1.5x. Okay? And our yh, lambda square plus 3 plus 2.25 is 0. Sorry. So from here, let's say lambda is minus 1.5. Okay, so it's a double root. We have only one lambda, so our yh is c1 e to the minus 1.5x plus c2 x times e to the minus 1.5x. Okay, since it's a double root, we multiplying x to the y1 to get linear independent solution. Right? Then we should get yp. Okay, so our yp is according to the table, it should be the same as the given r of x, right? So that should be c times e to the minus 1.5x, correct? According to the table. All right, let's see. And yp prime is 1.5 c times e to the, oops, you see? We're going to immediately know that this one, same function is already in the homogeneous part. You can do this, and yp prime, yp double prime, you add the, plug it in, and then you compare, and you determine the coefficient. Let me skip that part.